For its size, New Brunswick is a province rich in rivers. The force that is in those flowing river currents is another form of energy that has long been used to generate electricity. NB Power owns 7 hydroelectric power stations. But by far the largest is the Mactaquac Generating Station, 15 kilometers above Fredericton on the St. John River. Mactaquac produces fully 10 to 12% of the province's electricity. That's the amount of electricity you'd need to light up 15 billion 100-watt light bulbs for 1 hour. The St. John River is one of the largest rivers flowing into the Atlantic Ocean. Over its 720-kilometer journey, it drains a vast area of New Brunswick, Maine, and Quebec. The St. John River and its tributaries account for 5 of NB Power's generating stations. The river empties into the Bay of Fundy, 135 kilometers south of Mactaquac, and there encounters a unique hurdle, the highest ocean tides in the world. At high tide, the St. John River is effectively blocked at its mouth. So, added to all the other calculations they do, Mactaquac engineers have to factor in this twice-daily restriction of the river's current. The Mactaquac Dam was constructed between 1965 and 1968. It was New Brunswick's biggest infrastructure project. 2,000 people were involved in the construction that at the time cost $125 million. Today's replacement value would be about $5 billion. 50 people work at the dam in operations and maintenance. Amazingly, for short periods of time, the facility could be monitored and run from the control room with as few as 2 staff. There are 2 main types of hydro facilities, reservoir and run-of-river. Reservoir facilities create huge holding lakes and can store massive amounts of water for long periods of time. Run-of-river facilities like Mactaquac depend on the constant flow of the river. Mactaquac only stores enough water in the head pond behind the dam for a couple of hours of operation. The purpose of the dam is to block and then control the river current. The water stored behind the dam is directed down and through 6 turbines, providing the energy to spin the 6 generators. The amount of kinetic energy from a dam system, energy available for motion, is determined by 2 factors. Firstly, the volume of water flowing through the turbine. Double the amount of moving water, and you double the power. In the spring, melting snow significantly raises the level of the river. The water flow can be 100 times greater than in normal summer conditions. Extreme rain events also periodically create a windfall of extra energy from nature. The second factor affecting energy is the pressure behind that water, what engineers call hydraulic head. This pressure is created by the weight of all the water in the head pond. Double the height between the water's surface and the turbine, and you also double the kinetic energy. Mactaquac has an operating hydraulic head of 34.1 meters. The dam itself rises 55 meters above the river level and spans half a kilometer. When it was constructed, it caused the river behind it to back up and flood an area covering 87 square kilometers upriver, as far as Woodstock. A 42-meter-high intake structure directs moving water into 6 steel tubes encased in concrete, known as penstocks. Each penstock is almost 9 meters in diameter and 55 meters in length, big enough to drive a train through. These tubes deliver 400 tons of river water every second to one of the 6 turbines. That's one Olympic-sized swimming pool about every 6 seconds. At the end of the penstock, the water passes through 24 wicket gates, which open and close like the shutters on a window. Each of the turbines must spin at exactly 112.5 RPM. To maintain this constant speed, the wicket gates respond to electrical changes almost instantaneously, regulating the flow of water to the turbine. This is all automatically controlled by a feedback device called the governor. For almost 50 years, these massive turbine blades have been rotating from the force of the river current. From here, the process will start to look familiar. The turbine is attached to a rotor made up of 64 6-foot-tall electric magnets. This rotor spins inside the coil of wire, known as the stator, and produces electricity. It's an extremely flexible source of power. The amount of electricity produced can be varied simply by directing more or less water through the turbines. The water behind the dam is effectively stored energy, like a battery recharged by nature. It can quickly be used in times of peak demand. And the generators can ramp up from a dead stop to full output in about 2 minutes. If you think about it on the scale of the New Brunswick power grid, turning Mactaquac on is similar to flipping on a light switch, compared to Belledune or Point Lepreau, where that's not possible. At certain times, spring especially, there's more water flowing in the river than can be effectively passed through the turbines. Mactaquac has 10 spillway gates that can be opened to let excess water bypass the turbines entirely and continue on downriver. Generally, the plant only runs at its maximum generating capacity of 668 megawatts during these peak high water flows. The rest of the year, it roughly averages 25% of its output capacity. This still provides about 12% of all of New Brunswick's needs. And that extra capacity can step in when other generating stations are offline for maintenance. Like wind power, water power is a free fuel, and the cost of producing electricity this way is very low. It's superior to wind in that it is predictable, dependable, and responsive to changes in demand. And hydroelectricity is one of the cleanest sources of electricity available. Mactaquac Generating Station burns no fuel in its direct operations, resulting in no emissions into the air and no greenhouse gases. There are, however, other environmental impacts anytime a river is dammed and land is flooded. The construction of the dam itself used a vast amount of materials, the production of which left a carbon footprint. Kilometers of riverbank were submerged to allow for the head pond. The normal flow of river sediment was interrupted, and it tends to build up behind the dam. The dam also profoundly blocked the movement of migratory fish such as Atlantic salmon and Gaspereau. Salmon were prevented from returning to the headwaters of the river each year to spawn. A fishway was constructed to transport migrating fish around the dam, and it is operated by the Provincial Department of Natural Resources. Hydroelectricity is a very minor contributor to climate change, but hydro station operators across New Brunswick see the effects of climate change very clearly. Warmer than average temperatures have altered the times and flow rates of the spring thaw and result in more intense rainfall events. The movement of water is changing, and this can be seen in increased electrical generation. In the last 10-year period, the province's hydro stations have regularly hit output levels that were hardly ever seen in the previous 30 years. What is the future for the Mactaquac facility? Unfortunately, the dam suffers from a structural weakness common to dams from that era. It's called alkali aggregate reaction. Calcium in the cement reacts with the surrounding crushed rock, causing all of the concrete at Mactaquac to expand. Inside the powerhouse and wall of the dam, cracks have formed. Slots have been cut to relieve the pressure in the moving building. While the impact of AAR does not affect the safety of the plant, it will ultimately lead to a shorter operating life, 70 years instead of 100. NB Power is currently examining options for Mactaquac following the end of its service life, now scheduled for the year 2030. The three options currently under consideration are refurbishing the powerhouse so that it continues to provide electricity from the St. John River for the foreseeable future, removing the powerhouse and building a new spillway without electricity generation in order to preserve the river in its current state, and 3, removing all of the facilities, including the dam, to return the river to its pre-1965 condition. Wind and moving water are two sources of energy that come to us freely. Hydroelectricity is clean and dependable. In addition to this, Mactaquac uniquely helps regulate and protect the New Brunswick power grid as it operates in cooperation with other types of generating stations. But the province has before it a major decision concerning the future of Mactaquac. What is the best path forward for the environment, the ecosystem of the St. John River, and the electrical needs of both industry and citizens?